Annoying. What did I tell you? Admit it, you were wrong. I hate to say it, I told you so, but I hate to say I told you so. Okay, so angles and centered position. Today's lesson is just a lot of terminology, but which is nice because it's pretty simple. We just have to, I don't know, you might want to get out your different colored pens for today. I don't know. Okay, so outstretched, there's two arms to every angle. There's the initial arm, and it's along the x-axis, so this would be what I call my initial arm. Right, that's usually always your initial arm is on the x-axis. That would be your 0 degrees. Okay, that's my initial arm. And then we have our terminal arm. And so the terminal arm is where our actual angle is. Maybe I'll make that a different color. I'll make it purple. Okay, so then we have our terminal arm. And that's the rotated from the initial arm to form an angle. And the angle we're going to form is what we call the rotation angle. So this angle here is our rotation angle. Okay. Now, see, theoretically, you could have an initial arm that's here, and you could have a terminal arm that's here, but that would make it too hard, right? And so it's possible, but this would be too hard, right? So instead, we have our initial arm always at 0 degrees, right? If we're always starting at 0, then it always makes our angles a lot more simpler to compute. Instead of having our initial arm somewhere random, then it's harder to figure out the angle in between at 0 degrees. So it's a lot easier that way. Okay, so why do we use standard positions? Or why this is called standard position? I'll fill in our angle. So 0, what would this angle be at the very top right here? If 0 is on the x-axis, the y-axis up top here would be 90, and then next the x-axis over here, 180, 270, and 360. Okay. So angles in standard position always open from the positive x-axis. They open from the positive x-axis. Again, because it makes it a lot, if we're consistent every time, then we can actually have some terminology. We can base our mathematics always to be the same every time, having our initial arm at 0. So it's opening up from that initial arm, which is always at the positive x-axis, and beginning at 0, 0. So we don't shift it to the left or right. We're always going to use our origin as the vertice that's connecting our initial arm and our terminal arm. So beginning at 0, 0. Or another way you could put that is initial arm and terminal arm will always meet at the origin. So there's some examples down below. You can see here, why is the first one not in standard position? Or is it? It's not because it doesn't begin at the origin. So does not begin at 0, 0. Okay, so it's not at the origin. Is the next one in standard position? Yes. Okay, our terminal arm and our rotation arm meet at the origin, so that's check. And our initial arm is on the positive x-axis, check, or 0 degrees. Okay, so C, is that one standard position, yes or no? No, what's wrong with it? It's on the negative x-axis. So the initial arm does not start from the positive x-axis. So that would not be an angle in standard position. That's what we call that, an angle in standard position. These are angles in standard position. So if we start from the origin and the positive x-axis, then we can say that angle is in standard position. Okay, draw the following angles in standard position. We're not going to use a protractor. We're just going to do a rough sketch. So if we know this is 0 and this is 90, 75 degrees approximately would be around here. So that would be approximately 75. So that we would say that's in quadrant number 1. Remember our quadrants, it goes 1, 2, 3, 4. So what quadrant would 105 degrees be? 2, yeah. It's 180, so 105 would be approximately, so starting from the x-axis all the way to our terminal arm, and that would be 105 degrees, right? Remember, we always start from the positive x-axis and origin. And 225, what quadrant would 225 be? 3. This is 270, this is 180. So it'll be about halfway. So here, so starting from 0, there's the 0 degrees, and all the way around to the terminal arm, that would be the 225 degrees. So we're always starting from origin and from the positive x-axis. Makes it a lot simpler. Okay. A couple notes. I want you to add something on the side here. Okay, and that's something called a reference angle. And we're going to talk more about a reference angle on the next page, but I would like you to kind of start getting the idea of it right now. So what is a reference angle? A reference angle is the distance in degrees, if that makes sense, from the terminal arm to the closest x-axis. So not necessarily the positive one, it could be the negative one. And the reference angle is going to be really helpful for us in the future. And it's very helpful for drawing the angle. All right? So let's go back after you write that down. We're going to actually draw in some reference angles. So in the first one, and always this is the case in quadrant 1, and your reference angle and your rotation angle are the same. So because that the terminal arm to the closest x-axis is the same, your reference angle, which we would denote with a little r. So this is how we denote the rotation angle, is just theta. If we have a little subscript of an r, that's the reference angle. So whenever we're in quadrant 1, the reference angle and the rotation angle are always the same. And the reference angle is always going to be an acute angle. So it's always acute. What does acute mean? Less than 90. Yeah, it's adorable, right? Because it's small, acute. Less than 90 degrees. So here, in the second example, our reference angle would be from the terminal arm, which is this arm right here, okay, and the closest x-axis. So in this case, our reference angle would actually be right here. This would be my reference angle. So from the terminal arm to the closest x-axis. So in quadrant 2, it's always going to be between the terminal arm and that 180. So what would that reference angle be? How would you calculate that reference angle in question B? Yeah, Justin? 180 minus 105, perfect. Which gives us, what's wrong with you today? I'm not talking to any of you specifically, just my computer. It doesn't want to wake up. There we go. Okay, so 180 minus 105, what does that equal? We can do that. Right? 75 degrees. Okay, so our reference angle is this angle right here. That was theta r. That's our reference angle. And we can get, and that's 75 degrees. So that can be helpful for drawing it, but it's really going to be helpful for calculating a lot of things in the future. Okay, C, what would the reference angle be? The reference angle in this case would be between the terminal arm and the closest x-axis. What's the closest x-axis? 180 or 0? 180. Okay, so this here, this angle right there between our terminal arm and our 180 degrees is our reference angle. So that would be the reference angle for this guy. So how would we find him? We know our rotation angle is 225. And we know it's going, our reference angle is between that terminal arm and 180. And I want to know this distance. How would I get it? Anybody? Yeah? Justin? Yeah, so or 225 minus, because we want a positive instead of a negative. You could go 180 minus 225 and then just take the positive. They would come out negative, or 225 minus the 180 will give you what's left over, and that gives us 45 degrees. So remember I said it was about halfway between the 180 and the 270. It's because our reference is 45, right? And our distance between 180 and 270 is 90 degrees. Okay, so that's a lot of information, hey? All right, let's turn the page. Okay, quadrants, we already talked about those. 1, 2, 3, 4. I guess what's important is in this quadrant, x is positive or negative in quadrant 1. Positive, and y is positive. Okay. In quadrant 2, x is negative, y is positive. Quadrant 3, they're both negative. Quadrant 4, x is positive, y is negative. Angles can be classified by their quadrants. Quadrants start from the initial arm. So remember, our initial arm is always going to be at that 0 degrees. And then they rotate, and it's going to rotate counterclockwise. Initial arm. And we're always going to go this direction, right? Counterclockwise. Now, the reason why the signs are really important, I'm going to get you to write something down. It might not make sense just yet, but it'll be good to have in your notes when you're studying. So our coordinates are always x, y, right? And so a lot of, we're going to be using, and you'll use this a lot, your x is going to be cos theta and your y is sine theta. Okay, so the x is going to relate to cos and the y is going to relate to sine. And that's when only if our radius is 1. Okay, and the reason why that is, well, we'll get into that soon. Okay, I just want you to write that down for when radius 1, that's going to be really important in this unit. So have it there, and then we'll talk about it more in the future. But it has to do with like cosine. If this is my right, rotation angle here, right? Cosine is adjacent over your hypotenuse. And if our hypotenuse is 1, well, you can't see that. Let me move it down. Okay, so remember cos is adjacent over hypotenuse, so really quickly. So if my adjacent is equal to x, and my right, that would be the x on the horizontal axis, and the hypotenuse is 1, that's why cos theta is equal to x. So it has to do with that. And then sine is your opposite over hypotenuse. So if again, our radius is 1, our hypotenuse is 1, we get y over, so sine theta is opposite over hypotenuse. Move that down. So we're going to get opposite is your y, hypotenuse is 1, and that's how you get sine theta is equal to y. Okay, that's why those are going to work out that way. It might be a lot of information right now, but it'll get easier, I promise. Okay. Okay, coterminal angles are angles that have the same terminal arm but different angle measurements. So, our rotation angle could be 40 degrees, but another angle that shares the same terminal arm is if we add 360. So instead we go around just having the 40, what if we go around the circle once and then come up to a rotation angle? That would be 400 degrees. And so those are 40 and 400 are what we call coterminal because they share, coterminal, they share angles that share the same terminal arm. That's why they're coterminal. Coterminal, they're sharing, right? Community, co-ops, co is sharing. So for example, what if I had an angle of, let's do a rotation angle of 105. Okay, can you give me a coterminal angle to 105 degrees? What could I do to get a coterminal angle? Just add 360. Okay, so if we add 360, we're going to go once, and then back, around, so 105. So 360 plus 105 is 465. Right? So 105 and 465 are coterminal. How many coterminal angles could we come up with? Infinite, right? We can keep adding 360. We could also subtract 360. You can have negative angles, and negative angles are going to rotate then in a clockwise direction as opposed to counterclockwise. Okay, so another coterminal could be this angle here. This angle here, if we're going to go, can you see the green here? Maybe I'll highlight it. Okay, this angle here, that would be a negative angle. So that one, the green one, would be 105 minus 360. What does that equal? I could do it. It's negative 255. Oops, that's a crayon, not a highlighter. Okay, so 105 minus 360, is that negative 255? Okay, so that would be another coterminal one, negative 255. If we move in a clockwise direction, we're moving in a negative direction because positive is counterclockwise. So that's another coterminal. So coterminal angles can be positive or negative, and there's an infinite amount of them. All right, we've already talked about reference angles. They're acute angles, less than 90. The vertex is at the origin. Its arms are the terminal arm of the angle and the x-axis. Note the reference angle is always in the same quadrant as the terminal arm. Okay? The key is that we're from the terminal arm to the x-axis. We never use the y-axis. Okay? We never use the y-axis in trigonometry. So what do I mean by that? What I mean by that is if we're doing 230 degrees, first of all, what quadrant is that in? 3, good. So 180, 270. So approximately 230, Okay, there's our 230.
Okay, so town is not even processed to be a light bulb order.
Okay, I thought.
Because the light bulb's $400 and a new projector is $700. And the light bulbs for the new projectors are only $100.
Okay.
So Yana said buy the new projector. So we're just gonna get you a new projector. But guess what? It takes 3 weeks.
Okay, that's okay.
So we have to figure out something else because this is like not working.
Reference angles. So 230 degrees. Now, what I don't want to see is this. Our reference angle is never, ever between the terminal arm and the y-axis. It breaks my heart. Okay, that's not how we do reference angles. Reference angles are always, and there is a good reason for it. But when we draw our reference angles, okay, reference angles are always going to be here, here, here. Oh, that is not a straight line. Let's try this again. So if this isn't it, here's my different terminal arms. Okay, our reference angle will always, just like the bow tie. These are our reference angles. You can have a reference angle here, 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 and here. Okay, it's between the terminal arm and the x-axis, always. Okay, and there's a really good reason for it, and we're going to discover that soon. So always, so make the bow tie. Okay, those are where our reference angles are. Is the bow tie, within the bow tie. So with this first example, our reference angle would be between the terminal arm and 180 degrees. That's where our reference angle is, always. So can you please calculate it? How would we find it here? It's acute. It's always less than 90. So in quadrant 3, okay, whenever we're in quadrant 3, we're always going to go our rotation angle minus 180 degrees whenever we're in quadrant 3. So in this case, our reference angle is my rotation angle of 230 minus 180. We want to take away 180 degrees, which gives us 50 degrees. Okay, so this is 50 right here. This is 50. Okay. It's always the bow tie. Okay, so let's try another one. 110. So if we're 110 degrees, quadrant 1, 2, 3, or 4? Quadrant 2. Okay, so 110 is approximately here. I don't know, it's a rough sketch. 110 degrees. So our reference angle would be, where would our reference angle be? Is it going to be up here or down here? Blue or green? I mean blue. Yellow. That's a yellow. I know my colors. Yellow or green? Yellow. Okay, good. Yellow. The yellow. Okay. Here. Let's try this. Is that better? Right? Blue on top, green on the bottom. Yeah. So it would be the green in this case. Okay, so reference angle would be between the x-axis, in this case the negative x-axis, and our terminal arm, because that's the part of the bow tie. So in quadrant 2, to find, whenever we're in quadrant 2, if I want to find my reference angle, I'm going to take 180 and subtract my rotation. So 180 minus 110 gives us 70. So 70 degrees. That's the reference angle. Okay? The reason why, everyone grab your calculators, make sure you're in degree mode. Oh, mine's already here. Okay. So, LCD. Okay, this is what I'd like you to do. I'd like you to type in sine 110 and now sine of 70. Sine 110, the question we just did, and then sine of your reference angle. sine 70. Okay, it's the same. It's the same. Now I want you to type in cos 110 and cos 70. Do you think it'll be the same? Is it pretty close? What's the difference? One's negative, one's positive. So type in tan now. Tan 110 and tan 70. Okay? One's negative, one's positive. So the reference angle is really important because ignoring the sign, are the ratios always the same? Yes. And that's why we always use between the x-axis and the terminal arm. See, if I use the angle that was between the 20 degrees, it doesn't line up. Cos of 20, let's do sine 20, and sine 110. There's no relationship between those two, right? That's why we always want to use the one between the x-axis and the terminal arm, because they're going to share the same ratios, ignoring sine. That's why they're important. Okay, and we're going to use that because we know they have the same ratios, we're going to use that to our advantage in the future. Because we can change them out, and if we can figure out the sign, then we could also figure out the answer. Okay? Alrighty. So with that, lots of talking today. Let's move on to our last page. Okay. Draw 4 angles with a reference angle of 20. What's our first option? Quadrant? Yeah, conveniently, how many quadrants do we have? 4. So let's do one for each quadrant. Coincidence? I think not. Okay, so quadrant 1, what did I tell you about your reference angle and rotation angle in quadrant 1? They're always the same. They're always the same. So when I draw the 20 degrees, okay, that's my reference angle and my rotation angle are the same thing. So finding a reference angle in quadrant 1 is the easiest thing in the world because it's the same. Quadrant 2. So if I draw a reference angle, it always starts from 0, 90, 180, 270. So we're going to start at the 180 and go up 20 towards 90. We're going to go up 20 degrees. Right? Okay. That would be a reference angle in quadrant 2 of 20 degrees. What would your actual rotation angle be then? 160. The rotation angle would be 160 if the reference angle is 20. Okay, quadrant 3, a reference angle of 20 would look like, again, we start from the x-axis and go towards the terminal arm. So our 20 would be there. It's always the bow tie. It has to be touching the x-axis, our reference angle. Right? Are always going to be with the x-axis. So what would the rotation angle be for quadrant 3? 200, right? 180 plus the 20, 180 plus 20. That would be my rotation angle. Okay, and quadrant 4, a reference angle of 20. Again, remember it's between the x-axis and terminal arm. What would be the actual rotation angle? 340. And we get that by going 360 minus 20. Easy? I hope so. Okay, what is the reference angle for each of the following? Do you want to try them yourself? Draw them out, find the reference angle, and then we'll go over it. Fine.